In this video, we will learn how to perform XY analysis using Microsoft Excel and the add-in, the stat add-in, free stat add-in. So we will learn how to do the Pearson's correlation, Spearman's correlation, and simple linear regression in this video. So first, let us open up the Excel practice file. So as we can see that we will have to open the remaining sheets here. There is a sheet called correlation. So this is the same example that we have been working with the insulin sensitivity with polyunsaturated fatty acid. So to perform the correlation, the Pearson's correlation, click on the data analysis, click correlation, and you have to put the input range. So input is that insulin sensitivity and percentage polyunsaturated fatty acids. So group by the columns because our groups are in the columns and there are labels in the first row. So as you can see the two labels here, and then the results will come up in the new worksheet ply. Click OK. So on the left side the sheet has come up. It says the the Pearson's correlation coefficient, that is R. So as you can see that it is 0.77 is a R, which is positive, and so that means that there is a positive correlation between these two factors. So it's not really clear which is influencing which, so that is very important. Is it basically the insulin sensitivity is influencing the unsaturated fatty acid, or vice versa, which is not really clear because the correlation does not mean causation. So that is very important thing that you should understand it. Now we can also perform the Spearman's correlation using the same data. Well, the Microsoft Excel do not support the Spearman's correlation, so you would need a real statistics add-in. So I click the data analysis, then you can go with the miscellaneous and check out where the Spearman's correlation is. Non-parametric test might have Spearman correlation. So it does not. The Friedman test is the goodness of it is there. So the Spearman's correlation is not there in that menu. So maybe perhaps in regression, Spearman is also not there in the regression. So then you can try with the correlation here. Correlation tests. I click correlation tests. So yes, there is an option for Pearson, Spearman, or Kendall. So I go with the Spearman's. So input range 1 and 2. So the first one, I click here and enter. The second range, unsaturated fatty acid, I click here, enter. And column headings are included. These headings are included, of course. Spearman's, and the tail is always 2. So instead of this, we go with the new worksheet ply. And I click OK. So this is the result of the correlation, the coefficient, the Pearson's correlation, which is identical to what we got in the Excel. Spearman's correlation is 0.74, which is quite similar, while Kendall coefficient is a little bit lesser. Now the alpha is the cutoff. There is nothing but the significance level. Rho is the same thing, the Spearman's rho. The p-value is that 0.003. So in the correlation, the p-value is not that important. What important is the correlation coefficient, or R. So this is how to perform the correlation. So now let us move on, uh, you know, to perform the regression using the same data set. So how to perform the regression using linear regression using the same data set. So in this one, we will have to click data analysis, and instead of correlation, let us go with the regression. So regression is right here, a regression. I click OK. So input of Y range is the first one it has. The Y range is the insulin sensitivity. The Y range is usually the insulin sensitivity, yes. And then the X range. X range is percentage C2022 polyunsaturated fatty acids. And labels are there. So, and of course you can also calculate the confidence level, and then the new worksheet ply would be the output including the residuals. So I click OK. So this one didn't come up with the the plot. So let us redo that once again. Correlation, data analysis, or regression. So all these are absolutely fine. So you would also have to click here, line fit plot. This is very important. Line fit plot. So the best fit line will also come up in this plot. I click OK. So you can see that the line fit plot has come up. So this plot I can just drag it here to make it a bigger one. This is a good plot. So as you can see, the summary here is ANOVA, the residual plot. So the most important value here in the regression is the R square as well as multiple R. So it is basically 77. These are identical to that of the Pearson's correlation, and this is what would like to see that, as well as the significance F and the p-value. You can see that the intercept p-value, you don't have to worry, but this this is the percentage C2022 polyunsaturated fatty acids. The p-value is very low, so it is quite significant, the result. So in the regression, it is usually the best fit line. So here the best fit line is not really apparent. So to make it more clearer, so you have to click here on, first you select the entire uh, the figure and go to the design tab, and quick layout, you can change that into this sort of layout. So here if you choose it, then you will see that I can just delete this one. So there are two things. So I can just put it here. So this is my equation 37.2x minus 486.54. So R square is 50.5929. So this is the best fit line of the linear regression. So this is a very convenient way to not the regression. So unfortunately it doesn't produce the 90 for the curved 95% confidence interval though. So the GraphPad Prism has got lots of advantage over the Microsoft Excel, but anyway, this is a workaround for that. So again, the residual output is also not presented in the graph-like manner, but still it shows the residual in tabular format. So this is the way to perform the regression using the built-in uh, manner. So let us also perform the regression with our somehow that has disappeared here. You can see that the add-in had been here, but now the add-in option has gone. Now I will have to, again I will have to do that. So now I can see the add-in here. So sometimes the real statistics add-in, there are some bugs in it, so it goes out and comes back. So that's very strange. I click here regression. So it's a linear regression I will have to perform. So I click OK. So input for the X and Y. So X is basically my this one, the fatty acid, while Y is my insulin sensitivity. Column headings are included, yes, and intercept and iterations, bootstrap. All right. So the regression, let us click OK. It will override. So instead of that, let us go with a new worksheet ply. I click OK. So as you can see that the regression, there is no curve produced, but only that it provides you the lower and upper with the coefficients and the standard error. So this is LAD regression of the correlation of this software. Is there any other regression? Let's try it out. Some other forms of the regression here. The linear regression is LAD only. That is basically working with the iterative one. So this is multiple and this is weighted linear regression. So polynomial regression, logistic, multinomial logistic, Poisson regression, ridge. So they are offering a number of regression, but the usual regression is missing here. So only option is that we will have to go with the weighted linear regression option. So let us click here. So input range X is fatty acids, while Y is insulin sensitivity. Column headings are there. Alpha is this, without any putting any weight. Output range is a new ply. I click OK. So the weights are required. So of course I don't want to put any weight. So there is no way that this can calculate. Now let us go with multiple linear regression with the same thing. Input range is basically the this one, polyunsaturated fatty acid, while Y range is my insulin sensitivity. So column headings are there. Now regression analysis, residual, Turbin Watson, and standard error type. I click here new, and let us see. So somehow it takes very long time. I hope it is not stuck up here. So it takes up really long time for performing the analysis of this the regression using multiple regression. So it's basically a linear regression with multi-factor. So as you can see that overall fit, you can see that R square is which is identical to that of the Excel add-in software. So this is the R square, and as you can see, this is the p-value, which is quite low. Again, it doesn't produce any best fit line. So basically the regression, whatever that this software, the real stat is offering, is not as good as I mean, it's just like the usual one, but the built-in regression is far better because it produces a curve, the best fit line. So I suggest you to stick with the usual, the data analysis tool pack, the regression best fit line, which we just saw that. So this line, but again, this line do not have any 95% CI, so definitely it's inferior than that produced by the GraphPad Prism software. Thank you for watching.